Hello, this presentation is on instantaneous rate of change, tangent lines, and normal lines. We first gonna be learning instantaneous rate of change, which means the rate of change at an instant, or if you wish, the slope at an instant. But before we do that, let's review some basics. Slope. So what does it mean? What does the slope mean? The slope compares the ratio of how one quantity changes relative to another quantity. In the case of equations with x and y, it is the change in y over the change in x. So the slope would be m equals the change in y over the change in x, which is same as saying delta y over delta x, which is the same as y2 minus y1 over x2 minus x1. Example 1, find the slope of the line below. So let's label the points before we find the slope. So -2, x1, -1, y1, 4, x2, 3, y2. So the slope m is y2 minus y1 over x2 minus x1. y2, which is 3, minus y1, which is -1, and x2, which is 4 minus x1, which is -2. And this is 4 over 6, which simplifies to 2 over 3. And what this means, it means when x changes by 3, the y changes by 2. That's what this means. Now let's look at the average rate of change. The average rate of change actually is the average slope. But if we are studying a function whose graph is a curve, not a straight line, so an average rate of change would be the better terminology to use, to describe the slope. But really, in regards to what it means, it's the same as the slope. So you say average rate of change or the slope, it's the same thing. Now, what is the average rate of change? So the average rate of change is the rate at which functions y values are changing as compared to functions x values, which is the same thing, change in the y versus the change in the x. So let's look at the function f of x on this figure. So on this figure, what we see the curve, which is f of x, and there are 2 points. First point is a comma f of a, and the other point is b comma f of b. So since we said that the average rate of change has the same formula as the slope, so it means it is the change in y over the change in x. And the y would be f of b, or y2 if you wish, f of b. y1 would be f of a over b, which is the x-coordinate of the second point, minus a, which is the x-coordinate of the first point, which is exactly the same as the slope formula. And that equals to the slope m. Now, why are we using taking the average rate of change or the average slope? Because the graph of the function f is not a straight line. Therefore, each time you pick different points, you get a different slope. So for instance, if I pick this point and this point, so the slope between these 2 points is definitely different than the slope of the given 2 points, which are a f of a and b f of b. So as we see, if I draw a secant line between these 2 points, these lines are not parallel, so they have different slopes. So each time you pick 2 different points, you'll have a different slope. Because for that reason, we just say, okay, this is the average slope between these 2 points. But if it was a straight line, then the slope is the same at any point. Here's an example. It says find the average rate of change of the function f of x equals square root of x over the interval 1, 4. Let's make a graph of this. So the function square root of x, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So we got something that looks like this. Okay. Now we want to find the average rate of change between these 2 points. This is 4, 2, and this is 1, 1. So we say the average rate of change, let's put AVE, is, let's write the formula first, f of b minus f of a over b minus a. F of b in this case will be f of 4, and f of a would be f of 1 over 4 minus 1. All right. Which is f of 4 is 2, f of 1 is 1, 4 minus 1 is 3, and the answer is 1/3. Let me show you a different way how you do this, just in case. So let's write average equals, again, f of b minus f of a over b minus a. So this would be a, and this would be b. So that means f of 4 minus f of 1 over 4 minus 1. F of 4, you gotta use this function to find the value of y that corresponds to x equals 4. So which means square root of 4 minus f of 1, which is square root of 1 over 4 minus 1. Square root of 4 is 2, square root of 1 is 1, 4 minus 1 is 3, and again, it's 1/3. So you can use either. I mean, it's the same thing. Now, finally, we are moving to the instantaneous rate of change at a point. So let's assume that we're trying to find the slope at a point. It's just one point, slope at a point. So it will be this figure, just a point. Now, if we have 1 point, then the change in the x is 0. Because if it's 1 point, there is no change. Then the change in x is 0. And the change in y is also 0. So let's try to calculate the slope at 1 point using the change in x is 0, change in y is 0. So please follow me on this. Instantaneous rate of change is a slope at 1 instant or at 1 point on the graph. If we attempt to find the slope at 1 point, then the change in y, delta y, equals 0. And the change in x, delta x, is also 0. So thus the rate of change is delta y over delta x, which is 0 over 0. And what is 0 over 0? It's undefined. So it means we failed to find the slope at an instant so far. because 0 over 0 is undefined, because dividing by 0 is not possible. So in order to resolve this issue, we need to use 2 points. So it's kind of a bit ambiguous because we're saying first it's the slope at an instant at one point, and then we say we have to use 2 points to find the slope at one point. Okay, what it is exactly is we're still looking for the slope at one point, but we look for the best approximation. So it means we use 2 points, and then we want these 2 points to be very close to each other. It means the difference between these 2 points is significantly small. And this is where calculus actually becomes handy. So we need to use 2 points whose difference is significantly small. The question is how small the difference must be so we can say it's significantly small. Well, that can be different from one opinion to another. But something for sure we gonna agree on is the difference has to shrink toward what? So it gotta be 0. So we want the difference to be very small, that is almost 0, or as close as possible to 0. And the concept that we have seen so far that deals with this type of issues, it would be something that is called the limit. So we use the concept of limit to find the slope at an instant. It means the limit as these 2 points or 1 point approaches the other point, or the limit as the distance from one point to another to the other point is 0. So we want these 2 points very close. So we want the distance between these 2 points approaches 0. So the limit as the distance approaches 0 between these 2 points. That's the idea. So now, in terms of the slope formula or the rate of change, it will be the same. It will be f of x minus f of a over x minus a. So f of x minus f of a over x minus a. So let me make a rough figure over here. Let's say we got something like this. Let's say this is a, and we want x to approach a from the left or from the right. It should be the same. Doesn't matter because the limit exists in here. The limit has to exist. So we're going to say this is a, and this is f of a. So a f of a, and we'll pick another point pretty close, and let's just call it x. So x f of x. Assuming this is zoomed in. So the slope would be this is x f of x, and this is a f of a. So just calculating the slope between these 2 points, it would be simply f of x minus f of a, as you see over here, divided by x minus a. But the only thing that we need to add is the limit of this ratio as x approaches a. So it means we want this distance between a and x to be as small as possible. X approaches a, it means the distance we want it to approach 0. Not equal to 0, but approaches 0. Okay, here's an example. So as example, if you find the instantaneous rate of change of the function f of x equals x squared at x equals 1. Okay, let's do that. Okay, so let's use the formula. So m equals limit. I'm going to write the formula first. F of x minus f of a over x minus a as x approaches a. So what is a in this case? A is 1. It is the x coordinate of that point. So a is 1. So we write limit, or let's make a figure for this situation. Say 1, this is 1, 1. So this would be the graph x squared. And then here's the point we're interested in. And pretty much we want the instantaneous slope at this point over here. So the formula says limit of f of x minus f of a over x minus a as x approaches a. So we said a is 1. So we have f of x minus f of 1 over x minus 1 as x approaches 1. So a is 1. Let's add a little bit more information here. So let's do 1 comma f of 1, and then we want some x that approaches 1. Some x approaches 1, so x comma f of x. Okay. All right, so now we have limit as x approaches 1. F of x is x squared. So we just substitute x squared for f of x. F of 1 is 1 squared over x minus 1. So if you find the limit at this step, plug in a 1 for x, it's going to be 0 over 0, which is indeterminate, so let's not do that. So this is limit as x approaches 1. What we want to do, we want to simplify. So x squared minus 1 factors to x plus 1 times x minus 1. We need to simplify because to get rid of the 0 over 0 indeterminate case. Over x minus 1. So the x minus 1 crosses with x minus 1, and what remains is x plus 1. Of course, now we can find the limit. 1 plus 1 is 2. So it means the slope of this curve at that point is 2. At that instant is 2. Now there is an alternate definition, which is same thing. It calculates the instantaneous rate of change at a point, but this is good when we want the slope to be at any point. At any point, it means at any point on the curve. At any point on the curve. So it means we come up with the slope formula, and then each time we want a slope at a different x, all we have to do is plug in the value of x in the formula, and we get the slope. So you're going to see how this works. So let's talk about this formula. Well, let's pick a random point. Let's say we pick this point over here, and we label its x coordinate by x. Now we need another point that is very close to this point. And this time we're not going to call it A. We're going to call it something else. So the distance, let's do this. So the distance, or the change in x, this change in x, let's call it h. So if the change is h, it means x has changed by h. It means this point here would be x plus h. That's what it means. The orange tick mark would be x plus h. So this point here, we're going to have the x coordinate of this point, which is x, and a y coordinate is f of x. And it's problem of space. X, f of x. And then the other point, this one here, it would be x plus h as its x coordinate, and a y coordinate would be f of x plus h. Now, if we find the slope in between these 2 points, you can draw a secant line in between these 2 points, but I'm just going to keep it like this. X plus h, f of x plus h. If we want to find the slope, then it's going to be straightforward. Then we want to say, okay, so m equals, I'm going to leave some space for something we need to put in there, but the slope formula would be f of x plus h minus f of x over x plus h minus x. And we want to simplify, so f of x plus h minus f of x, that remain the same. However, if you notice on the bottom, we got x and x. X minus x is 0, so the only thing that remains on the bottom is h. But what is h? H is the distance between, or the change, if you wish, the change that took place at that instant. And we want this change, as we said, to approach 0. So it means I need to add the concept of limit as h approaches 0. So limit as h approaches 0. And this is the alternate formula to find the slope at an instant. So let's scroll down. So we say as the second point, let's look at the figure, as the second point approaches the first point, or as h approaches 0, the slope at x f of x, x f of x, you can look at the figure to see x f of x, becomes instantaneous. Therefore, the instantaneous rate of change of the graph of f of x at the point x f of x is given by, it's the formula we just derived, m equals limit, so we have to add limit as h approaches 0 of f of x plus h minus f of x over h. And this is actually the most common formula in calculus. It is used probably 90% of the time, or even more than the first formula. So this is something we definitely need to know. Okay. As an example, find the instantaneous rate of change of f of x equals x squared at any given x. So if you want to sketch a graph, it's going to be a parabola. Okay, so something like this. X squared. And we want the slope at any given x. So we don't have any specific point here, but the formula we're going to come up with is in terms of x, and therefore each time we need the slope at some specific point, all we have to do plug in the value of x of that point into the slope, and we get our instantaneous slope. So let's start with the usual, which is the formula. So limit of f of x plus h minus f of x over h as h approaches 0. As h approaches 0. Sorry, I'm getting some troubles. Let's So h approaches 0. Okay. Our f of x is x squared. So what is f of x plus h? F of x plus h is x plus h squared. What is f of x? That's x squared. It's given over h. Oh, sorry, I forgot the limit. So let me write it down. Actually, here is better. So limit as h approaches 0 of x plus h squared minus x squared divided by h. And then let's FOIL and simplify. So we got limit as h approaches 0. X plus h squared is x squared plus 2xh plus h squared minus x squared divided by h. And this is the limit as h approaches 0. If you notice, I did not bother by substituting 0 for h at this step, because if you do, then you're going to get 0 over 0, which is an indeterminate. That's why I'm trying to simplify first. So notice that x squared minus x squared, they cancel out. So it would be limit of 2xh plus h squared over h. Now h is a common factor, so divide everything by h. 2xh by h is 2x. H squared by h is h, and h by h is 1. Now we're ready to substitute 0 for h. It will be 2x plus 0, which is simply 2x. So our slope is 2x. And what that means, it means if we need the slope at x equals 1, for example, it means the slope at this point, slope at that point, sorry, so 1, which means the slope at this point, all we have to do is plug in 1 for x, which becomes 2. So slope at this point is 2. If we want it at 2, so the slope at 2 would be 4, and you can tell, see the slope here, the slope over here is much steeper than slope at this point. And you see then 2 times 2 is 4, which is a bigger slope than 2 at x equals 1. All right, next thing would be the tangent to a curve. Tangent to a curve, which is a tangent line. If we have a line that is tangent to a curve, it means the tangent line touches the curve at one point, as you see over here. So what's so special about this? So we know that a line, the slope of a line is the same at any point. So it means the slope at this point is the same as the slope at this point, same at this point, same, and so on. But what we're interested in, it will be the slope at the point of tangency. Now, the idea is this. If I know the slope of this line, the tangent line, then I know the slope of the curve at this point. And then I know the slope of the curve at that point. The opposite is also true. If I know the slope of this curve at this point, then I know the slope of the line. And that is something that comes in very handy in calculus. So let's work on example 5. Example 5 says, find the slope of the parabola y equals x squared at the point 2, 4. Actually, we don't want to do the work, because in the previous example, we have already found the instantaneous slope of the parabola x squared at any given point. Now, if we want it at this point, we can just use the formula. So m at x equals, this is x. So at x equals 2, this is just a notation. This means the slope at x equals 2 is, the formula is 2x at x equals 2 and which is 2 times 2, which is 4. So we have the slope, which is 4. I have the slope and I have the point, which is 2 comma 4. Talking about this point, 2 comma 4. So I have the point, which is 2 comma 4. I have the slope, which is 4. So now what do I need to write in the equation of a line? I need the point and the slope, and I have this information. So I'm going to say tangent line equation, tangent line equation. Tangent line equation, let's use the point slope form. Y minus y1 equals m times x minus x1. Y1 is 4, so y minus 4. The slope, we said it's 4, and x1 is 2. And then we can simplify this to y equals 4x minus 8 plus 4, which is minus 4. So this is the equation of the tangent line. And if you sketch this tangent line, let's try to graph this tangent line. The y-intercept is -4. It's all the way down there. I don't have it available, but and the slope is 4, but it's going to be something. It's going to be something like this, something like that. All right, last concept, which is normal to a curve. Normal to a curve means perpendicular to the tangent line. So if you take a look at this curve over here, and notice there is a tangent line in blue. In blue, there is a tangent line. And the normal line, it would be this one. It's a line that is perpendicular to the tangent line. So it means if you have the slope of the tangent line, then writing the equation of the normal line becomes algebra 1, kind of problems. It means if we know the tangent line slope, the perpendicular line, which is a normal line, would be the negative reciprocal. And then it's the same point at the point of tangency, so all you have to do is use the point and the slope. All right, given f of x equals x squared, write an equation for the normal to the curve at x equals 1. So we already know the slope at any point of the function x squared, so we're going to use that again. So m equals, we found m equals to x earlier. That's the slope at any point. Now, the question says, given f of x equals x squared, write an equation for the normal to the curve at x equals 1. So all I know is this. This is the curve, and this is at x equals 1, and the tangent line will be this. The normal line, it will be the perpendicular line. This is the scenario over here. So if I can determine the slope of the tangent line, then I can determine the slope of the normal line. So this would be normal, and the green would be tangent. Okay. How do I find the slope of the tangent line? Well, slope of the tangent line is at any point will be 2x. And if I want this at x equals 1, I want you to learn this notation. So this is notation you can use. The slope at x equals 1, which is the slope is 2x at x equals 1. Then all you have to do is substitute 1 for x, so it will be 2 times 1, which is 2. So the slope is 2, but this is the slope of the tangent line. So this is tangent line slope. You need the slope of the normal line will be the negative reciprocal. So normal, let's use orange. So normal line slope, which is a perpendicular line, is the negative reciprocal of the tangent line slope, so -1/2. Now I have the slope, which is negative 1/2, and I have the x-coordinate of the point, I can easily determine the y-coordinate of that point by substituting 1 for x in the function f. So I can write y equals f of 1, which is 1 squared, which is 1. So the point P will be 1, 1. Now you have the slope and you have the point. So the equation will be y minus 1 equals negative 1/2 times x minus 1. Then if you simplify, it's going to be negative 1/2 x plus, I believe, 3/2 when you simplify. And this is the equation of the normal line. This is the end of the presentation. Thank you for watching.